Hello, Proshun, are you there? How is my voice? Is it fine? Okay. You start the live streaming like when we start the. Uh, okay, so you already started the streaming. Okay, okay, fine. So, a very good evening to all, and thank you for joining here in today's talk. So, almost after 2 years, we are again back to the physical or in-person event in IEEE Student Branch, IIT Kharagpur. So, it's a great pleasure to have amongst us today Professor Uttam Ghosh sir. And yeah, so all of you as well, because we survived this pandemic, and with the grace of God, today again we are resuming our in-person talk in our student branch. So all of you, those who are joining us today in virtually, so thanks to them as well. So we are now going to start this event. So a very brief introduction to our guest speaker, who will be speaking today on secure softwarized networks for next generation CPS and IoT. So Dr. Uttam Ghosh is obviously very well known to all of us or many of us because he is alumni of IIT Kharagpur itself. So to state a very brief introduction to our speaker, so Uttam Ghosh joined Mehari Medical College as an associate professor of cybersecurity in the School of Applied Computational Sciences in January 2022. Earlier, he worked as an assistant professor of practice in the Department of Computer Science at Vanderbilt University, where he was awarded the 2018 and 19 Junior Faculty Teaching Fellow. Dr. Ghosh obtained his MS and Ph.D. in Electronics and Electrical Communication Engineering from the India Institute of Technology, Kharagpur, India in 2009 and 2013 respectively. He has postdoctoral experience at the University of Illinois in Urbana-Champaign, Fordham University and Tennessee State University. Dr. Ghosh has published more than 90 papers at reputed international journals including IEEE Transactions, Elsevier, Pringer, IT and Wiley, and in top international conferences sponsored by IEEE, ACM and Springer. He has co-edited and published 6 books: Internet of Things and Secure Smart Environments, Machine Intelligence and Data Analytics for Sustainable Future Smart Cities, Intelligent Internet of Things for Healthcare and Industry, Efficient Data Handling for Massive Internet of Medical Things, Deep Learning for Internet of Things Infrastructure, and How COVID-19 is accelerating the digital revolution. Challenges and opportunities are the name of those books. So he's a senior member of IEEE and a member of ACM and Sigma Psi. So with this very brief introduction, I'm welcoming Professor Ghosh to start the talk. Thank you, sir, for accepting our invitation and came all away from USA to here. So without any further delay, I'm just handing over the stage to our speaker.
From here,
So a few more announcements. So today we are going to, this is a hybrid event, so we are having in-person talk from IIT Kharagpur campus, and across the participants are joining by Google Meet. We are also streaming this event live on YouTube, so it will be there. So any of you would like to revisit the talk can go to our channel and can see the recorded session. So that's it. So you can ask your question in between the talk maybe or after the talk as per your wish. You can, those who are joined online, please put your question in the chat box. At the end, we'll take the questions like verbally from all of you. You can unmute yourself and ask. And obviously the live audience here present, you can ask questions during or at the end of the talk. So thank you. So enjoy the talk.
Thank you, Devarsi, and good afternoon. Okay, thank you. IEEE Student Branch and Kharagpur section. I would like to present this talk mainly to revisit what is SDN network, and then I'll introduce 4 use cases. Why we need this SDN, why we need softwarized network. So I'll present that part. And here in this talk, or in this PPT, whatever the images we used, mostly cited here. And in this talk, first I will introduce what is softwarized network. So what is softwarized network? First I will introduce, then I will introduce what is SDN. I will give you an overview, and then I will present 4 use cases where we can utilize this softwarized network. Like say, first case is say smart grid, then smart city, 5G networks, and also you can integrate this softwarized network in data center. And then we'll discuss what are the issues we have in SDN network. So first, what is softwarized network? So softwarized network, again, the network will be controlled, monitored, and managed by software. So that means there should be a tool. Using that tool, we can control, monitor, and manage the network. So for that, we have tools like SDN. We have tool that is called NFV. So SDN and NFV technically both are same. But here there is a debate. There should be any difference or not, but there is no difference. Only thing is, if you are in US, then people will say it is SDN. If you are in Europe, then they will say it is NFV, because you cannot virtualize the hardware. So European people, they think this, but in US, people can say network can be virtualized, switch can be virtualized, and as a result, we can say it is just a SDN network. Right? So that is another part. So in this talk, we also discuss this network slicing, because this softwarized network main feature will be slicing. The slicing concept will be, we have a physical network. From the same physical network, we can create multiple virtual networks. Those are called slices. So using those slices, we can develop our own application. So we'll discuss all those. And then next is, before discussing this softwarized network, first we'll discuss what is SDN. Just we'll give you overview, then we'll discuss in detail. So first, why this concept came. So here is the issue. Today, whatever the network we are using, that is, we can say it is a legacy network. So in a legacy network, generally we are buying some switches from Cisco or HP, and then based on their requirement, actually we are configuring. But it should be different. As we are paying, then we should develop our own application based on our demand. But it is not happening. So that is the main issue in legacy network. That is the main issue in present network. So that's why we need softwarized network. So here, if you buy a switch from Cisco or HP, then both plane will be there. There will be control plane, there will be data plane. So control plane, as we know, control plane mainly it will be responsible for generating the routing table. Because in a router, there should be routing table. Based on the routing table, it will forward your packet from source to destination. Now, this control plane and data plane both should be there. And here, this data plane, mainly it is responsible to follow the instruction from control plane. So that means you have routing table. Using that routing table, you need to forward the data using data plane. Right? So here, first is control plane, then next is data plane. And then we have optional plane that is called management plane. So in this management plane, there will be special port. It is called management port. Using that management port, if you attach your computer, then you can configure the switch. You can configure each port. You can switch on. You can switch off that port easily. So that's why it is called management port, and also it is optional, right? Next is, so as this is a legacy network, in a switch, when you are buying from Cisco, they have their own operating system. They will provide their own application. Now, this application or these functionalities we cannot modify. Just you can think we have Windows operating system. We have Windows operating system, but there is no source code. As a result, we cannot modify anything. Right? So here also same thing. So just here we have our switch. This switch we purchased from Cisco. Now whatever the interface they are providing, based on that only we can configure. But it should not happen. Because as we are paying, based on our demand, we should configure the switch. Say today I have some demand, tomorrow I may have some different demand, then this switch should be programmable. Right? So that's why here, first of all, this switch is complicated. Next is it is vendor dependent. We need to still we need to depend on Cisco or HP. And then third problem is here, if you want to develop your own application, you cannot add. You cannot develop your own application. So that will be the most challenging task here. So that's why there is a need that is called software-defined networking. So here we need a new network that is called software-defined networking. Here in software-defined networking, you can configure, you can monitor, you can manage the network through software. That is called network operating system, also called Sdn Controller. So now the difference. So we have now legacy network, and there will be software-defined network. In legacy network, it is a closed network, as we cannot modify anything here based on our application. Whereas Sdn, here just we are separating the control plane from data plane, and now this control plane is now logically centralized. Here, this Sdn controller, it is presenting just operating system. As it is operating system, we can add our own application using C code or Java code, right? So that depends on your controller, which controller you are using. Based on that, you can develop your own application. So here, the concept is now these are switches. These are not normal switches now. These are called open flow switches. These are dumb switches. They don't have brain. So whatever the instruction the Sdn controller is saying, they have to follow because they do not have any brain anymore. So now the architecture will be, we have now 3 planes. First plane is called data plane, also known as infrastructure plane. In this plane, all the dumb switches will be there. These switches are called open flow switches. Next plane is called control plane, where Sdn controller, also known as network operating system, will be there. And at the top, there will be application plane. Now, there should be some interface. So this interface between data plane and control plane, it is called open flow. So open flow is just a protocol. Using this protocol, switch can interact with the Sdn controller. Now, when someone is sending any packet towards destination, he has to contact to the controller. So for this, we have open flow protocol. So this protocol should be reliable. This protocol should be secure also. For that, we are using TCP protocol for reliability purpose, and for security purpose, we are using SSL. Next is this Sdn controller is now very important. Why? Because this Sdn controller, it will now manage the whole network, and also this controller will be programmable. Now, based on your requirement, you can add your own application here, because this is just an operating system. Next is this controller has to monitor all the devices, and it has the global view of the network, underlying network. As a result, it knows the present status, which path is congested, which path is not congested. Next, it knows which path is secure, which path is not secure. So that means from here, you can even without even you can choose the path, which path is best, which path is less congested. You can choose according to your requirement. So because it has the global view of the network. So for that, we are using some different protocol that is called LLDP protocol. Using that protocol, you can generate this view from the Sdn controller. Next is, now we can define what is Sdn. So Sdn means it is just a separation this control plane from data plane, where this control plane can manage several devices at data plane. Now, features wise, we can say first it is programmable, because controller is programmable. Next is we can abstract control plane from data plane. Then third is controller is logically centralized. It will be easy to manage the network. Whereas distributed network means once you run any routing protocol, thereafter there will be no control over the network. But here it is not. Next is, this is programmatically configured. On fly, if you know there is a path, that path is, there is a malicious or attacker node, on fly through controller, you can change the path. And most important part is, it is open standard, based vendor neutral. Now no need to depend on Cisco or HP, because the network is programmable. So the working principle will be very simple now. So this is Sdn network. So this is host, H1 and H2, they are hosts. And these are open flow switches, they do not have brain again. Then this is Sdn controller, this is just a server. You can install Windows or Linux. Then at the top of Linux, as an application program, you can install network operating system. That may be controller, that controller is, we have several controllers available like Knox, Fox, then floodlight. So one of the controllers you can install here, then based on your controller, you can develop your own application. Now in this diagram here, H2, say suppose this is source node and he wants to communicate with H1. Now in this case, what will happen? So first this packet will be forwarded to S3 switch, and then this S3 switch, as it is down, he doesn't know how to forward the packet. So as a result, he has to contact to the controller. So in step 2, it will forward that packet to the Sdn controller. Now Sdn controller, it has the global view. It knows the present condition of the network. As a result, this controller, it will send the flow rule. It will send the flow rule. Or you can say it is just a, for this switch S3, it will send the flow rule like this, S3. Then once it receives the packet from S2 host, it will forward the packet to S2 switch. So here the action is forward. Even here, based on your controller or based on your requirement, you can drop the packet also. So if you need security or if you need to implement like firewall, action can be dropped also. Right? So here at step 3, this controller, it will send the flow rule to the corresponding switches, and it will give you the best path in terms of security or in terms of say congestion, or it may be in terms of number of hops. Now at step 4, that packet will be forwarded from S3 switch to S2, then S2 to S1, then finally S1 to H1. Now at step 5, from the second packet, when this S3 switch will receive the packet from H2 host, this time it will not forward that packet to Sdn controller because it knows how to forward now. Right? So now it will be just like a flow. So there will be now flow from H2 host to S3, then S2, then S1, and then H1. So there will be continuous flow until that session is over. Right? Once this session is over, then this flow rule will be deleted from the table, from this switch, because there is a limit. Now in a switch, there will be at most 1500 flow rules like this. So this is one flow rule for the switch S3. So such type of rules we can install here, 1500 at most. And that's why there is a time. So once the timer is time out, then we need to delete that flow rule from the table. Now next is why we are using Sdn then. So main reason is, so this is not a main reason. Main reason is this dynamic slicing. So here this concept is virtualization. So this virtualization concept even in traditional network also we can achieve, but there will be, as the network is distributed, as there is no control, so there is no centralized control, as a result you have to face the challenge. But in this case, as the controller is logically centralized, no need to go here and there. From the controller here you need to write a application program, and from that application program you can create multiple groups based on their IP address, based on their MAC address, or based on their ID. So for in this diagram here, say host 1 and host 4, you can create a group that is a virtual LAN 0. Like here host 2 and host 5, you can create another group that will be say virtual LAN 1. And this logic here you can write. So this will be now very simple. Just you need to write a code, few lines. Next is this dynamic slicing. So this part is very important, and because of this reason, these days this 5G or this Sdn concept we are integrating with 5G communication, IoT communication. So because of this feature, and when this Sdn concept came, at the time actually this cloud computing concept, because of this cloud computing concept, actually this slicing concept also came. Here in this diagram, you can see this is a physical network. Now with the help of provisor or hypervisor, you can create multiple virtual networks logically. So here in this diagram, you can see this is virtual network 1, that is another is virtual network 2, but we have same physical network. And here we are creating this virtual network 1, 2 logically with the help of provisor. So here, now this is slice 1, another is slice 2. Now this slice 1, especially in cloud computing, so we have multiple cloud service provider like Google, like Amazon. Now when we are getting service from Amazon, at the time our demand will be, we need our own protocol, we should have our own routing, we should have our own addressing like IPv6. you may want IPv4. So based on our demand, based on the demand of the tenant, we can choose the protocol. So for that, this slicing will be important. Now, when I'm communicating with the Google server for cloud, then I can use slice 1. If someone wants service from Amazon, at the time they can use slice 2, because in slice 2 they can run their own protocol. So this part is, that's why it is important. Now this concept we are also utilizing in 5G communication. Next is service integration. Now it's easy because whatever the service or network functionalities we have, we can implement it easily. Like here, this firewall. So firewall in traditional network, it's not easy. But here it will be very simple because at the top of Sdn Controller, as an application, you can write the code. So for example, we need to block the HTTP service, that web server. So for that, we need to drop the packet if the destination port is 80. So that simple logic we need to write here. And that file is a firewall.c. If you compile, if you install here, just it simply drop the packet whenever someone is sending packet, and if the packet is containing destination port as 80. Now, same way we can balance the load balancing can be implemented. With the same concept, you can implement the intrusion detection system. So only thing is you should have your own logic. Which packet or which flow we should allow, which flow we should not. So now this Sdn concept we are integrating not only in cloud computing, we are also integrating Internet of Things, next generation communication like networks like 5G, 6G, and then infrastructure-centric networking, critical infrastructure like smart grid. Now, this Sdn, if you know, this Sdn can be, we have an emulator. This emulator is called Mininet. Using this emulator, you can simulate the Sdn network. So there is a command. So in Linux platform, if you install this, so it's very simple to install. Just type sudo apt-get install Mininet or mn. It will install from the internet automatically. Now once you install this Mininet, then just type sudo mn. It will create this type of network. And you can see there will be one controller, and then there will be lot of virtual switches. So this is virtual switch, this is virtual machine. So this type of network will be created easy. But this whole network is virtual network. Next is, this is the state of the art. And now here we have 3 planes. At data plane we can see, if you want to buy switch from Cisco or HP, you can buy. But these are all dumb switches. There will be no control plane. Now, next is, if you want open source software switch, say suppose you have laptop. That laptop can be working as a switch. For that you need this software. So we have many softwares. These are all open source. You can download. You can install inside your laptop. Then your laptop will be behaving just like a switch. Next, we have control plane. At control plane, you can see there are multiple controllers available, and all these controllers are freely available. So you can download and you can use. Only exception for PFC controller. So this PFC controller, it is not free. You need to purchase the license. And here also we have multiple controllers. This is Open Daylight controller. This Open Daylight controller, it is based on Java. Then say Fox controller, it is based on Python. So whenever you are developing any application at the top, you need to write the code accordingly. Next is, we will discuss now four use cases for the software network. So first we will discuss IoT enabled software smart grid network. So smart grid, so this work I did when I did my postdoc at Singapore. So at that time I did this work. So this was, I think, in 2016. So at the time just Sdn concept was new, but we are not sure this Sdn concept can be applicable for smart grid or not. So that this was the first step. So this was just a study. So for this we implemented a test bed. One is real-time test bed, another was simulation-based test bed. Then what we did, so here we injected multiple faults, like when if Sdn controller fails, what will affect in smart grid communication. So that type of thing we implemented here. So here we implemented The cyber physical system using two simulators. One is Firewall. Firewall is a simulator for simulating power grid or smart grid. And Mininet is a emulator for emulating the SDN network. Now, when two simulators we are integrating, what will be the main problem? Main problem will be synchronization, timer. If you have two simulators, they have their own timer. So that was the main issue. So when we work here, so at the time we solved this problem. And then we implemented this IEEE 37 based bus system. And then we shown if controller fails, how it will affect smart grid communication. Then we also implemented this hardware test bed. For this, we purchased some switches, open flow enabled switches, then some Raspberry Pi. Then we made some substation, sensors, actuators, and to mimic the smart grid communication. Next is in the next work. Here we realized if you use SDN actually we should use for smart grid network, provided you have multiple controllers in SDN enabled smart grid network. If you have single controller, then there is no way. If the controller fails, whole network will fail. As a result, smart grid communication will fail. As a result, the whole country can be blacked out. So that means without multiple controllers, you cannot think. So that at the time we shown. Next is when we realized, okay, SDN controller SDN is actually applicable for critical infrastructure like smart grid, but at the same time we realized as it is critical infrastructure, chance of attack will be more. And now when you are using communication network, the attack surface will be that space will be increased, I think. Now when we are integrating this SDN, here the network will be like this. Here we have control center. Through this control center, we can control this smart grid network via this communication network. Now, when we are integrating this SDN concept, here we should place this SDN controller, and here there should be SCADA master. So this SCADA master, if you know, SCADA master just like a big server. So using this server, you can monitor, manage all the substation, all the devices from the substation. And in general, these substation devices are known as SCADA slabs. Next is, here we are deploying some sensor. Generally, the sensor will send the data from the substation. Then it will send this communication network to the SCADA master. Now SCADA master, it will process the data, and based on that, it will send the feedback again via this communication network. And then using this actuator, this substation will execute the command, whatever the instruction they are getting from the control center. Next is this SDN controller we are using mainly for controlling and managing the communication devices. Now, when we integrated, then we realized that there is a chance of attack also. Now, this SDN controller can be compromised physically. SCADA master also can be compromised physically. Communication network also, there can be attack. In substation also, there can be attack. Even there can be bad data also. This sensor can generate bad data also. So for that, first we categorize what type of attacks possible. So if you say protocol based, this open flow protocol is related to Mininet, or it is related to SDN network. Whereas this DNP3, this protocol we are using for smart grid communication. Now all these protocols are vulnerable because there is no security aspect. Next is if you consider location based, inside attack, outside attack, both possible. Now if you consider device based, then SDN controller itself is vulnerable. Then smart meter. So smart meter will attacker can modify. If you can modify the smart meter, then no need to pay the bill. Right? Next is PMU, phasor measurement unit. That device also can be attacked. So there are several attacks. Now to protect this SDN enabled smart grid network, we just propose this framework. Now here we have a substation. From our point of view, as we are networking people, from our point of view, this is just a local area network. This is another local area network. We have a wide area network, then there is a control center. Now this substation to substation communication is possible. Substation to control center communication is possible. For this we need wide area network. Now as we need to protect all the devices, as we need to protect the communication network, for this we are just deploying security controller. One will be local security controller another will be global security controller. Now this local security controller, it will run some intrusion detection system, then it will monitor all the devices, who is misbehaving or not. Next, at the control center, we are deploying global security controller. Here also we are deploying IDS system. This IDS system, it will monitor all the devices at control center. In addition, it will monitor communication from one substation to another substation. So this is just a framework, but at the time we didn't consider how to detect a device is malicious or not. So for that we need to use some machine learning tool. So the policy which node we should detect as malicious, for that we need some machine learning based algorithm. Next this is another case where we can utilize this softwarized network concept in smart city to implement smart city. So generally in smart cities, we are using IoT. So IoT devices we are using like sensor network, GP network, Bluetooth or mobile ad hoc network. Now this you can say it is just a heterogeneous network. Now in a smart city, there will be smart home, smart building, and smart vehicle communication. Now when you are implementing in a smart city, then definitely there should be some smart city control center where we can monitor everything, where we can control everything. Now when you are implementing this, obviously the layering architecture should be same. Like IoT architecture, even you need to consider Sdn architecture also. That's why we have 3 layers. First layer is called infrastructure layer. Then we should have 2 sub layers. First sub layer is called IoT devices. Here all the IoT devices like Zigbee, sensor, all the devices should be there. Next sub layer is called forwarding devices, where all the gateway nodes should be there. Then next layer is called controller, where Sdn controller should be there. One should be local controller for controlling the LAN. Another controller should be there, that is called global controller, where it will be placed to at the city control center. And then at the top there should be service layer. At this layer we can get all the services. It may be related to network or it may be related to IoT, like smart building or smart home or smart healthcare. Then when you are using this concept, definitely first issue will be addressing, because in a smart city we are deploying multiple thousand of sensors, thousand of IoT devices. Now how to identify them? First option is RFID. Next option is IP address. Definitely we cannot use IP version 4 because we have limited address space. That is why we need to use IP version 6. So IP version 6, it is 128-bit, and as a result we have large address space. And in IPv6, first 64-bit or first 8 bytes is called network ID. It is fixed for a network, so that is, you can say, this is the network ID. And rest of the 8 bytes, that is called host ID, and it will vary host to host. Now here this diagram is actually presenting byte by byte address, and you can see, you can choose any node, you can see that node has unique ID, unique IP address. You can see each node has unique ID, but this tree is just an example. Now here what we did, so whenever a device joins the network, IoT device, at that time it will be client. It needs IP address and it will ask to the neighbor, I need IP address from you. And whoever is neighbor, he will assign the IP address to him. So that means this protocol, this protocol itself is distributed. Initially I am client, I need IP address. Once I get IP address, then I will be acting as a proxy. I have capability to assign the IP address to the new devices. As a result, this network will grow like this. Next, here this is one of our PhD student. He is working, so I am guiding along with Professor Radha Datta. He is my PhD supervisor. So here we are also using this softwarized concept in 5G networks. So here in 5G networks, again, first is this unreliable and low latency communication. This is important for critical service, like say healthcare, maybe smart grid communication, industrial automation. There we need this. Why? Because this ultra reliable and low latency communication it will tell you can achieve almost 99.9% reliability and few millisecond delay whenever there is a packet transmission. Right, and this is needed in 5G communication. This is one of the most important requirement in 5G network. Otherwise, we cannot consider this critical service like say healthcare, maybe industrial automation. There we cannot tolerate delay more than 100 milliseconds there. Now, when we are using this 5G network, again, this 5G network, whatever the base station we are deploying, the base station should have higher signal strength because we need to achieve better data rate whenever we are downloading or uploading something. Next, the bandwidth should be more. Then only it will be applicable. So when we are using this 5G network, at the time if you use centralized approach, then this approach will not provide anything. Like URLC, you cannot achieve. So as a result, we need to use softwarized concept. So using this softwarized concept now, you can control the network again. The signal strength also you can control, the area or the cell size also you can control. Now in this work, first when you are placing this controller, as we are integrating Sdn concept here, first question will be asked, how many controllers we need? Because 5G network is not a local area network. It is a wide area network. Obviously, we need many controllers. Question will be, how many controllers we need? This is pure optimization problem. Next is where to place the controller. You can place here and there, it is not. So this is another problem. Third problem is why we are using Sdn here, because main objective is to create multiple slices. And using those slices, we can achieve all those requirements. Like one slice will create from the same physical network, and that slice will be allocated to for say industrial automation. Another slice will be created, that slice will be allocated for smart vehicular communication. Third slice will be created for say healthcare. So that will be the main objective. Now when we are creating the slice, it should be dynamic, it cannot be static, because whatever the resources are available, and from that same resource, how much resource you can allocate from the device, you need to decide. So this also important. Now when you are creating slice, at the time this slice is secure or not, how much you can trust, that is also another question. So here, first is when we are integrating this Sdn concept in IoT network, here you can see how many controllers we need. Actually it depends on this cell size. If the cell size is large, you can see if the cell size is large, then here the handoff will be less. But if the cell size is small, you can see the handoff will be more. From here to, if they are moving towards this side, then the handoff will be more because the cell size is small. Next is here how many controllers we need and what will be the cell size. There should be trade-off, there should be some optimal solution. So here in this area we are working now. Next is when you are creating the slice. So here we have example in this diagram. You can see this is physical network. Now we created multiple slice, multiple virtual networks. So this virtual network 1, this is for industrial automation. This is for slice 2, this is for healthcare. Then third slice is for smart vehicle communication. Now, if you consider this device, this is logical device now. Now this device, it may have multiple ports, it has some memory. How much percentage we are allocating for this slice, how much percentage we are allocating for this slice, that is also another question. So here, when you are creating the slice, which resource is available, how much you can allocate from that resource, that is also another question. So here, when you are creating the slice, again, here we can use some concept of machine learning, like federated learning. Next is when you are creating the slice. So here we are creating the slice, and then there should be network slice manager. With the help of network slice manager, we can virtualize the function. So here no problem, but if attacker somehow you can inject one network function in this chain, then this slice will be failed, and as a result, it will fail. So here also we need to consider whenever we are creating the slice, that slice how much we can trust, and it should be secure. Again, here we need to use some machine learning tool or security tool like authentication, something we need. And whatever is happening, most important part is one way we can say SDN can provide security because SDN controller is programmable. There you can write your own program, you can implement firewall easily, you can implement intrusion detection system easily. But at the same time, SDN itself is vulnerable. We have 3 layers, all the layers are vulnerable. So for a simple example, if this device is sending large number of packets, every time it is spoofing its IP address, it is spoofing IP address and sending continuous packets to this switch. As a result, this controller will receive and it will send continuous flow table. And as a result, all the switches will be their table size, that it will reach to that level, and then the buffer or the table will overflow. And as a result, in the worst case, there will be no service or the authorized node will not get service from the network. So then it is called denial of service attack. So each layer we can see there will be attacks. Now, before applying this SDN concept in any network, we need to make sure we can protect SDN itself or not. So if you can protect, then better we should integrate, because SDN, it has many features, but at the same time it can bring new attacks also. Next is, this is little different because here this concept again we are applying in healthcare. So this concept we are just presently we are working in this area. So here an unbiased data analysis for addressing health disparity and equity using trustworthy AI. And here we are just using some concept of softwarized network. So here first we should know what is health disparities. So health disparities, if you know, in US one of the major issue is this racial. So in healthcare also this problem can be seen. For example, now I am working at Nehru Medical College. It is under HBCU. That means historically black colleges and universities. So in our college, I think around 100% people are from African American. Whereas where I worked earlier, Vanderbilt University, most of the patients, they are actually from white American. Now, when you are using some machine learning tool, traditional machine learning tool, AI tool, if you consider the data set from Vanderbilt, whatever the result you are predicting, same algorithm, if you apply for Nehru Medical College, if you predict something, this prediction will be totally different, right? And why this is happening? Because of healthcare disparities. So now, what will be the solution? Solution should be we should get access the data from Vanderbilt University. We should get access the data, patient data from the Nehru Medical College. Now, why they will share? If they share, then again we need to follow this. If they share their data, if Vanderbilt is sharing their data, then we need to make sure we can provide this confidentiality, integrity, and authentication. This is the standard for HIPAA. HIPAA, if you know, like IEEE, HIPAA is the, in US, they are actually maintaining the standard for healthcare. Whatever happening in healthcare, they will decide which will be standard, which will not be standard. Right? So here, when we are sharing the data for a patient, what information we can share, what information we cannot share, they can tell. Like in US, if you know, every person there should have social security number. And when you are visiting any hospital, first they will ask your social security number as well as your insurance. Otherwise, they will not enter the name. So now when you are visiting another hospital, when they are requesting the data from Vanderbilt University, what information they can share or they cannot share, those will be decided by HIPAA. Sometimes when they need to share, then the patient has to sign, he has to agree that I am willing to share the data, and Vanderbilt will share the data at the time. Now in this case, what is happening? So we have data now from Vanderbilt University, we have data now from Nehru Medical College. Now traditional AI, main problem is if you consider this data, there will be bias. So Vanderbilt data, if you consider, there will be biasness. If you consider the data for Nehru, there will be biasness. Now there should be some solution for this. Next is traditional AI. Another problem is if there is any bad data in the data set, then it cannot predict the result accurately. Third problem in traditional AI, if the data set is small, again the result will not be accurate. So to overcome all these problems, we should consider the trustworthy AI or next generation AI. So in that case, so this is just we are working in this area now. Recently, we submitted a proposal to NIH. So NIH is actually that is the healthcare National Institute for Healthcare. So we actually submitted this proposal recently. So we have multiple objectives. So first objective is to use this trustworthy AI because we need to get data from Vanderbilt, we need to get data from the Mary, but at the same time we need to consider this privacy. We need to preserve the data privacy concept. So for that we need to use trustworthy AI. That is called federated learning. So federated learning is actually concept is distributed. There may be multiple data source, but if you use federated learning, you can preserve the privacy. So here, that will be the first objective. Then we can use digital twin, other things. Then, at the final step, we need to validate our result. So for that, we should have our own test bed. So that test bed here we are using, that is software-defined AI-enabled data center. So here we are using again Softwarized or SDN concept. So this is data center or cloud, but here this is Softwarized AI-enabled data center. Here we are just not only virtualize the network, we are virtualize the machine. That means we are virtualizing the computing part, networking part, and the storage part. So here these three things will be virtualized. So with the help of virtualization tool, we can compute that means we can create multiple virtual machines. With the help of SDN, we can create multiple virtual networks. With the help of another tool, we can get storage also, virtual storage. Now, this will be our test bed. With the help of this test bed, whatever the algorithm we will design in future, those will be related to trustworthy AI. Those trustworthy AI algorithm will be tested here. Then this is just an initial attempt. So here, if you consider this layer, here this layer is presenting the data source, medical data sources. So here this is say healthcare, this may be hospital, there may be ambulance. There are multiple sources for this healthcare data. Now all this data we can upload to cloud. Now at the cloud there will be mixed type of data. There will be patient, that patient may have diabetes, the patient may have cancer, but all the data will be stored here. Now when the doctor, when someone is accessing the data from cloud, for him it will be difficult and there will be long delay also. Now how to reduce this delay? For that first, when you are storing here, after storing the data here, we need to classify the data. So again, here we are using machine learning tool to classify the data. Once you have data, once you classify the data, then based on the data type, you can download to the ACE server. So this ACE server is actually, it will be near to doctor. So this doctor, when they are accessing the data, they will access the data directly from this edge computer. It will not ask to the cloud because cloud will be far away from his device. So here, after classification, the data will be stored here based on the data type. If it is related to cancer, the data will be stored here. If the data is related to say COVID-19, the data will be stored in edge server 2. So that way we can store the data, and as a result, when there is surgery, whatever the data we need for surgery, the related edge computing server will be accessed for that. So here just this is an initial attempt. Only thing is here in this work, we are just trying to reduce the delay whenever the doctor is accessing the medical data. And here also we need machine learning. Here also we need 5G communication. Right, so this is just presently we are working in this area, and 5G communication, when you are uploading the data set at cloud, at the time also you can use, when you are accessing the this edge server, at the time also you can use 5G. Just it will give you the speed to upload or download the data. That's all. Or for this application, you can allocate one slice for healthcare. So that's what we have seen. So if it is healthcare, this slice will be there. If it is regular communication, this is another slice.
base station to the open switches, how they are connected. The wireless or through wireless.
So now we have both options. Both options are available.
So if wireless is there, then the reliability is there because the total plane of it is there.
Yeah, so reliability, if it is wireless, definitely reliability will be the issue. Yeah.
So how I'm going to decide if
So if in that case, you need to make sure the signal strength is high. Right? So here in 5G communication means also wireless, right? So as it is wireless, still you cannot say the reliability will be 99.9%. But how to make sure we can get 99.9%? In that case, the cell size should be small. The base station, the signal strength should be high, but at the same time, it should cover only small area. Then every time we'll get signal, and as a result, the internet speed will be always high. Bandwidth will be more. Right? So that is, otherwise 4G and 5G there is no much difference.
it was moving to the high.
Yeah. Yeah. Otherwise, we cannot create this type of slices. Right?
Because the slices is in the software version.
So this slice only you can achieve through SDN or NFV. Now this. Yeah. Yeah. If you have question, you can ask.
So I have one basic question. So, like in SDN, you are always considering centralized approach. Right? So, can there be any issue with the scalability?
Centralized, logically centralized. It is not centralized. There can be multiple SDN controllers, right? But it is not that only one controller is there. But all the controllers logically centralized. Now in 5G networks, obviously one controller is not sufficient. That's why we are deploying one controller here, another controller here, and there should be link between them also. So there should be one more interface between them. Otherwise, there will be synchronization issue. Right? So we need definitely multiple controllers. Now, when we are using multiple controllers in the same network, then there will be synchronization issue. One controller can send X command, another controller it can say different thing, and it can send Y command. And as a result, the dumb switches will be puzzled. Right? So there will be synchronization issue. But at the same time, that interface between two controllers, that should be also reliable, and also it should be standard. Right? And present that we are using BGP there, BGP protocol.
Is there any other questions?
So if you use single controller, then definitely that single controller, that single point of failure will be there. So if the controller fails, whole network will fail. Now, if you use multiple controllers, then only you can get the reliability. And also, otherwise you can use backup controller. One controller will be active. If that active controller fails, at the time backup controller will be active.
Another question, like when you are showing that for the IoT devices, you are taking the ID or the ID. Rather than going for the distributed approach, why are you not taking the centralized approach?
A centralized approach here, as IoT network is large network, right? So if it is centralized server, if it is a centralized DHCP server, dynamic host configuration protocol server. Now, if the server is here, if your device is here, he has to discover the DHCP server. For that, he has to broadcast a packet from the network, and that complexity will be device square, where n is present in that number of devices in a network, and the delay will be how much from here to there. That is, it will be round trip delay. In addition, there will be there. That will be 2 times t, where t is present in there, t is present in the delay from your device to server. But here, in this case, the complexity will be only big O, because it can get IP address from the neighbor, and also the latency for this addressing will be only 2t. That means from your device to server, because each device will be acting as a server. As a result, he can get IP address from his neighbor. And once he has IP address, again it will become proxy. But definitely the last one, once it is here, after that there will be no IP address available. And as a result, no one will get IP address available. And that is definitely right, because we are already exhausted the IP address. Now here also in this protocol, if someone leaves from the network, that IP address again, this parent can keep it. for future purpose. If someone comes, again it can be allocated. That this IP address again it can be used if someone leaves from the network.
Like estimate of the controller for the IoT network. So that problem is also dynamic, right? So
Yeah, dynamic, correct. That's why here this cell, we consider this cell size is large, right? Now here handoff will be less because the cell size is large. If you move from here to here, there will be no handoff. But if the cell size is small, like here, now you are moving from here to this side, then again handoff will be there. Again you need to shift to here, and there will be load to the controller, right? Because controller is now doing everything. So now there should be trade-off. How many controllers we need, where to place it, and when you are placing, at the same time we need to consider the handoff also. This handoff also should be minimized.
like when you are solving the problem, are you assuming that all these things are known? How do you solving the optimization problem without the like?
So we are solving. That's why he is
Well,
working.
I'm asking sir, like, are we assuming that all these things?
Now this is NLP related problem. So this is optimization problem, right? Yeah. So this is just optimization. Again, you need to consider objective function.
Those demands, like all these things are.
There will be multiple parameters also. Yeah. So all those parameters like bandwidth, delay, all those parameters also will be considered in that function, right? Objective functions. So obviously there is a challenge, no? That's why we are working. So this work actually just is published also. So this paper, if you explore, you will get. Yeah, this is the first paper. This paper.
It's actually lots of question.
Other question আছে তাহলে পড়ে বলো।
Okay, so let's move to the online questions. I don't know whether I'm audible or not, but let's take the online questions now. So Sommariza is here. So Sommariza is asking that, hi Dr. Ghosh, thank you for the nice and informative talk. Can you please comment on the specific security issues in 5G network slicing that one needs to consider apart from the traditional security issues like IDS and firewall? This is the one.
Security issue.
Yeah. So apart from the security issues, traditional security issues, what are the key or specific security issues?
So traditional security issues are there. In addition, slicing security is the main issue now.
What are they?
Fake slicing, creating fake slice, that is the main issue now. Other security issues are already there.
So the second question is from Suji Manna. What's the big challenges of securing IoT devices? What's the big challenges of securing IoT devices?
So traditional cryptographic technique we cannot use because those are IoT devices. If you use small sensor, then it has limited battery power. So if you use public key cryptography, then if you run any cryptographic algorithm, the sensor itself will die because of the cryptographic tool. So there should be light cryptography you can use, or some other technique like identity-based scheme, or maybe say task-based protocol. That type of thing we need to use. Or access control we can use. So if you use traditional cryptography like RSA, if the key size is 2048 bit key, then it will take long time to encrypt the message to decrypt the message. So the sensor will die itself for that. So as a result, either we can use task-based protocol, or we can use some lightweight cryptography. Now ECC cryptography is there. So that cryptographic technique should be lightweight.
So another question is from Tanushree Parvat. Sir, I have a question. How to secure our IoT-based application from CPS-related attack? Cloud is also insecure to upload the data. Then how to protect those data from outside?
So here, when you are using network, obviously the network, there is a chance of attack. If you want to protect your network, definitely that network should not be connected to outside world. Now, if you are connected with the outside world, we have mainly, you need to focus on two things. First, you just consider you have a house, and then you are protecting from outside people using your house. Now, inside house, there will be separate room. That means you are protecting now from your family members. That means there should be some privacy among family members. Now, that means we need two walls of defense. So, as a tool, as a first wall of defense, generally we are using firewall or cryptography. Either we can use firewall or cryptographic technique, where authentication we need. For confidentiality, we can use public key cryptography. If you need integrity, message integrity, then in that case we can use message authentication code, or maybe we can use digital signature. Right? Next is, if you need, say, device security. For that, you can use access control. There should be a list of ID, and there should be some type of master device like access point or maybe base station. It should contain that list. Whoever is authorized, if his name is there in that list, he'll be authorized to access the resources, otherwise not. So that type of access control mechanism should be there. So using this concept, you can protect your network from outside people. Now inside people, it will be more challenging because they are the family members. You need to trust them. They are authorized people. Now how to protect? For that, you need to use second wall of defense. For that, we are using either trust-based protocol, or we can use intrusion detection system, where this system will monitor all the devices, whatever the packets they are generating, all the packets will be mirrored to the IDS system, and it will inspect. So we have, for that we need to write some policy. And even now, today's date, we have third generation firewall. So earlier we used first generation firewall, that is called proxy firewall, packet filter firewall. So packet filter firewall, at the time, we can filter the packet based on IP address, port address, source IP, destination IP. Accordingly, we can filter the packet. Which traffic we should allow into our network, which traffic we should not. Now we have second generation firewall. So second generation firewall, if you use, then you can filter the packet not only based on IP and port number, even you can filter the packet based on the packet content. If the packet is containing any malicious code like virus, worms, you can filter the packet, because there will be proxy server. Whenever you are sending the request, first that proxy server will receive that. It will verify if there is any malicious content, if there is malicious code like virus, worms, then it will drop. Otherwise, it will allow, and it will forward the request to the actual server, actual HTTP server. Now, here the problem is, here we cannot track all the session or all the packets from start to end. So throughout the session, we cannot monitor everything. So for that reason, we have now third generation firewall. That is also called stateful inspection firewall. So if you know TCP protocol, in TCP protocol, there is a three-way handshaking before sending any data. So that is called three-way handshaking. So there will be SYN segment for synchronization from client to server. Server will send acknowledgement and also SYN, that will be piggyback, and then this client will send acknowledgement. So that will be three-way handshaking. Now, at that time, if there is any attack or if there is any modification in that packet, like port address is changed during this communication, that also can be detected by this firewall, third generation firewall. Because this third generation firewall, that's why it is also known as stateful inspection firewall, because it will keep the state, whatever is happening in your network. If there is any misbehavior, it can detect easily. But it will be complicated also.
So another question is here. Software or hardware security, which one is preferred and why? By giving the software answer.
So some cases are there where we cannot provide hardware security. So for hardware security, we are considering TPM mainly. So when you are booting your system, at the time key will be generated. So somehow it is good, because no need to depend on for key distribution. Generally, we are depending on key distribution for KDC we can use, or trusted third party TTP we are using. Now, if you have this hardware, then no need to depend on them. But if you have trusted third party, then there will be advantage also. There you can change the key regular basis. So periodically you can change the key. Then the chance of attack will be less.
স্যার হয়েছে স্যার। আচ্ছা স্যার, ঠিক আছে স্যার, ঠিক আছে। হ্যাঁ হয়ে গেছে, ঠিক আছে স্যার। Okay, so I guess this is all. So if you have any further question, I will share the contact details of sir. So you can ask the questions to him. Okay. If any of the questions still remain not clarified properly or from the online and also the physical audience, so please feel free to discuss with sir. You can like discuss now also. He will be here for today itself. So that's it. So with this, we'll be concluding the event today, and on behalf of IEEE Kharagpur section, a small token of appreciation to you, sir. So thank you for accepting our proposal and coming.
Thank you for everything.
Dear participants, so thank you for your patience. So we are here right now concluding our session. So stay tuned for the next sessions, and thanks to all of you.